Hi guys, Godwin here. Another reviewer tayo ngayon, this time for CALENG2, integral calculus. Though this isn't really something that your profs would teach you, although it's something very interesting. I just came across this while I was watching. I forgot whose videos were they actually. Feeling ko like flammable maths or something like that. It's called the Dirichlet integral. And it's under this form, the integral from 0 to infinity of sine x over x. So normally, kapag indefinite integral lang siya, like without the limits, the upper and lower limits, this would be impossible to integrate without like calling in another function, which sabihin natin, if you were just to say this, ayan lang, you would have to call another function called si of x para, anong tawag dito? So that you can just arrive to the answer. So it can't be expressed in terms of polynomials or like any other special functions. Anyway, so what we're doing right now is the integral from 0 to infinity of that Dirichlet integral. So it is possible, and it's a nice round value, which you will learn later. And ang nilagay kong hint dito is the Fubini's theorem. If you guys are aware of Fubini's theorem, if ever hindi nyo pa naririnig, maybe you've heard of changing the order of differentiation. So if ever, ano tawag dito, we have a function that's in terms of two or more variables, and there are however many integrals that match yung integrals na yun, yung variables na yun, and that the limits of them aren't functions of one another, you can freely switch between the orders of the differentiation. So, for limits that include functions, maybe you need to do some more work before you can properly reorder. But for now, ang ano lang naman natin, ang limits lang natin is 0 to infinity. And I said here na I can also use 0 to infinity. It doesn't matter. So, to be honest, when I first heard about this, syempre I did like, what do you call this? What is that? I forgot what that's called. I'm sorry. It's the VDU is equal to UV minus, wait lang. UV minus integral of UdV. There. Integration via parts there. Thank you. Thank you, me. Okay, anyway. If you do that, you'll end up in a really, really complicated dead end. So I don't recommend you do that. Pero, keep this in mind, this hint. And like, just try pulling something. Try pulling something from, inside your mind, like how it would happen that we would use another integral just to solve this. So, I guess another further hint is that, anong tawag dito? We will think about, for the most part, yung sine x lang. Kasi, the trickiest part about this integral is getting the over x, right? Kasi sine x, that's pretty easy. It's just negative cosine x if you integrate it. And then for 1 over x, it's just ln of x, right? If you integrate it. But what happens when you put them together, right? And so we need to find a function that recurs, as in, hindi siya nagagalaw if ever you integrate it or you differentiate it. And if ever na nagagalaw siya, it would spit out this 1 over x term. So what kind of function would do that? And sige, I'll let you guys like pause this video siguro if you start to have any, and what do you call this, any ideas you might have. And let's just return here when you've finished your spitball session. So I actually didn't think about this before. I mean, I was thinking of using, of course, exponential functions, right? I wasn't expecting to use something like this. Okay, just write down the limits first, 0 to infinity and then 0 to infinity. Ang nakalagay, I found this proof in Proofwiki. It's, they started off with e to the negative xy. You can call your second variable anything naman, there's no problem. And then sine of x dx dy. And so, okay, let's analyze this integral first. So, sabihin natin we derive this in terms, derive tuloy. We integrate this in terms of y first. So, since Fubini's theorem applies here, since both of these limits are okay, they're not functions of one another, we can just switch the dx and the dy so we can integrate dy first, right? And so if we do that, hold on, let's remove the equal sign for now. Let's make it pink, sige. So we'll do this, and then just for clarity, I'll add parentheses. And we'll do e to the negative xy sine x dy, and then dx. So ito muna yung titingnan muna natin, yung nasa loob. And so, since everything here, even the sine x here, is just a constant, walang problema. You can just do 0 to infinity. And then, pwede mo na itong ilabas yung sine x since it's just constant, right? Sine x. And then, we can just, we can just integrate this, mentally. Since e to the negative xy and then y yung variable natin, we need to have a negative since magka-cancel sila if you derive it, and then e to the negative xy, and the one in here should be x, right? And then 0 to infinity, and then dx. And then actually, you can already, what do you call this? You can already remove this this over x sa ilalim, since it is just a constant, right? So we already have our sine x over x here. And let's just check if this is 1 actually. So tingnan natin. Sine x over x. And then we'll substitute infinity first. So that becomes negative. And then let's do this actually para madali. Negative infinity, so that becomes e to the negative infinity is 0. So I'm hindi siya legit na step, but it's a mental leap na, because for you to have a correct solution, like a rigid correct solution, you're gonna have to set a limit and then replace the infinity with something like b, and then set the limit as b approaches infinity, and then that's your answer. But you know that you have the what do you call this? You have the intuition already na e to the negative infinity. If you scroll down to the left of the exponential graph, it always tends towards 0. So 0 minus, and then times 0 naman siya. So yung y natin magiging 0. Negative x times 0 is 0. So negative, we pulled out the negative. So e to the 0 is just 1. And then 0 minus 1 is negative 1. And then negative of negative 1 is just 1. So tama tayo na this indeed does arrive to the same the same Dirichlet integral that we've been presented at the start. Now, of course, the correct solution now would be if we tried it the other way. The other way being kung inuna natin yung x instead. So we will have, hold on. Sine x dx, and then dy yung nasa labas. Okay, so we should have, at the end, an integral only in terms of y, right? So we have here an exponential and a trigonometric function. So we'll have to actually break this down first. So I guess we should go on a tangent here. I'll just write the thing down again. 0 to infinity of e to the negative xy sine x dx. I think that's it, right? And this is where we actually use our integration by parts. And so, let's try assigning. We should assign. Okay, I'll just assign the du here, as sine x dx para hindi tayo mahirapan. And then, so the u here, if we integrate this, should be negative cosine of x. And then, for the other one, v should be e to the negative xy. And so dv should be negative y e to the negative xy dx. Okay, and so we'll just plug in this to here. And, okay, para hindi na tayo malito in the future, I know that this is going to recur from our experience in CALENG2 if we have an exponential and a trigonometric function like sine or cosine, it's going to recur. Like if we apply it, integrate it by parts, it's only going to recur. So I'll just add here equals I. We'll come back to that later. It's not important for now. So we'll just apply this. So u times v is this thing, negative e to the negative xy cosine x minus, and then u dv, so this is negative, so that cancels out. This still becomes negative, right? So y e to the negative xy cosine x dx. And so this is in terms of x, so we can actually remove the y. We can put the y outside the integral. We can do this. And now we have this one, which is just the same as I, but instead of sine, you have cosine. And so we'll set it again. We'll set this again. Du is equal to cosine x dx. And then u is equal to, of course, sine x. And then v now is still the same. And then dv is negative y e to the negative xy dy. And so, mag-parenthesis tayo when we encounter this term, minus y times, so this is now u v, so e to the negative xy sine x, yes, okay, minus, this is negative times positive, so it cancels out with this one, it becomes positive. And this is the integral of, ano ba to? U dv, right? So, y e to the negative xy sine x dx. So we can also put the y outside the integral sign. And now, ayun nga, just like what I've said before, this integral right here and this integral right here, they're identical. So I can replace that with I. And so this will be an algebraic expression now. I is equal to negative e to the negative xy cosine x minus y. I'm going to distribute now. Y e to the negative xy sine x plus y times y, that's y squared, I. Oh, sorry. Forgot to distribute the negative also. So positive, negative times positive, that's negative. There we are. And so we have here, if nilipat natin to sa kabila, we'll have I times 1 plus y squared is equal to negative. Let's group these terms together according to negative e to the negative xy. Matitira is cosine x, and then plus y sine x. And then finally, we're going to have our integral, which is the integral of, we can remove this for now. There's no problem with that. So we won't be solving for the limits pa. The integral of e to the negative xy sine x dx, that is just equal to negative e to the negative xy of cosine x plus y sine x all over 1 plus y squared. Okay, so now we have that. And we have this now. Since meron tayong limits from 0 to infinity, okay, let's go. Saan na pa tayo? Okay, here. We can remove the negative ata, no? Yes. Okay, let's just keep it here. E to the negative xy cosine x plus y sine x all over 1 plus y squared from 0 to infinity dy. Okay. So, immediately nakita ko kaagad and I panicked because I just realized we're going to have to plug in infinity inside cosine and sine, but it doesn't matter because I also forgot that they are attached to e to the negative xy. And so let's just do this really quickly. We'll have the negative sign here. Okay, yeah. And so if we plug in infinity here, this becomes negative infinity. E to the negative infinity, of course, that is 0, right? And then if we apply 0 here, and sabihin natin, okay, we apply 0 everywhere to the wherever the x is, sine 0 is 0, cosine x is 1. So we'll be left with 1 times e to the 0. E to the 0 is 1, so of course that's also a minus 1 over 1 plus y squared dy. So we are left with 0 to infinity of dy. Yes, I am one of those people. Dy over 1 plus y squared. And so yeah, most of us I think already know what the equivalent of this is. But I know for the people who want to review, let's try to review. For now, this might not look something like a trigonometric function, but inside meron kasi siyang connection. So let's review right here. Of course, the most famous let's use theta instead. The most famous trigonometric identity, of course, is sine squared plus cosine squared is equal to 1. Yeah, there we are. And a less known version of this is if you divide everything by cosine squared, this becomes sine squared over cosine squared, which is tangent squared, plus cosine squared over cosine squared is 1. And then 1 over cosine squared, that's 1 over cosine squared. I would say that, pero you can also say secant squared, right? And what's also interesting here is if you take the derivative of tangent, it becomes 1 over cosine squared, which is also secant squared. I don't want to go over how tangent theta, if you derive it, becomes secant theta. Kaya nyo na yan. Okay, so we'll be using that property here. And I'll be using integration by substitution. Sige, let's use theta na talaga. Let theta is equal to, baligtad nga. Let y equals tangent theta. Now, if we derive both sides, that should be dy is equal to the derivative of tangent of theta. That's going to be secant squared theta d theta. Okay. Sige. So actually, just so we're what do you call this? Just so it's more convenient, let's just take the indefinite integral of this muna. So let's go on another tangent here. Dy over 1 plus y squared. We know that dy is equal to secant squared theta d theta. And so what is 1 plus tangent squared theta? Of course, that is secant squared from here. And of course, they cancel out. And then you are left with d theta. Of course, that's just the integral of 1. So of course, it's going to be theta. Theta plus c plus c. I also forgot to add plus c here, since it's an indefinite integral. But anyway, what's theta though in terms of y? So we know that y is tangent theta. So how do you get just theta? Of course, it's going to be arctangent of y is equal to theta. And so, this is actually, arctangent of y plus c. Yeah, so that's how you do it. So now this becomes arctangent of, arctangent of y from 0 to infinity. All right. I actually want to show another way how to arrive at, if you derive arctangent of theta, you'll get this, arctangent of y, you'll arrive at this point. So let's just do that really easily, really quickly lang. Oh no, I can't change my pen color. Anyway, sige, let's have ano na lang. Y is equal to okay, sorry. Let's have arctangent of x. Ayan. Since we're more like familiar with arctangent of x, kasi we're working with y as a variable here, that's confusing. So we're trying to get what y prime or what dy over dx is, right? And so we can do that if we just do this. If we apply tangent to both sides, it's horrible handwriting. If we apply tangent to both sides, it becomes tangent of y is equal to x, right? And from, what's that called again? Implicit differentiation. If we differentiate both of these guys in terms of x, this one has y, right? But it's a variable, so we can just do whatever the derivative of this is. Oops. Whatever the derivative of this is, and then we just tack on dy over dx. So this is 1 over cosine y, 1 over cosine squared y, and then multiply lang tayo by dy dx. And of course, the derivative of x is 1. And so we're going to get dy over dx is equal to cosine squared y. So, job done. Oh, oops. Job done, finished. No, but we actually need this in terms of x. Kasi yun naman talaga yung original natin, diba? And so we're going to do, what do you call this? We're going to apply what tangent of y equals x really means. So tangent of y is x, which is just x over 1. I'm doing this because I'm going to use so, ka, tawa. And we know that tangent is equal to opposite over adjacent. So I'm going to make a triangle, a right triangle, with an angle of y. This is really weird, I know. With opposite as x and 1 as adjacent, right? And so, of course, our hypotenuse would be 1 plus x squared. I was going to write x squared plus 1, but mas familiar if we have 1 plus x squared. Anyway, so now we know what cosine of y is. Cosine of y is adjacent over hypotenuse. What's our adjacent? That's 1. And our hypotenuse, which is square root of 1 plus x squared. And of course, if we square that, we're going to get our magical formula of the derivative of arctangent of x is equal to 1 over 1 plus x squared. And so, ito na, last na. So, what's the arctangent of infinity? So, it's asking what angle, if you put it inside of a tangent, will result in infinity. And so, nalaman natin yan, if we just draw a simple like tangent graph here. We know that tangent is periodic, but for arctangent, we're just getting this, this boundary lang over here. And then we know that as this rises up, it gets nearer and nearer to x equals pi over 2. And so we write here pi over 2 minus arctangent of 0. What's arctangent of 0? What angle, if you input it inside a tangent, would result in 0? Of course, that is 0. And so finally, we have the answer to the Dirichlet integral. Let me just rewrite. Ayun, I can change my pen colors now. Okay, ayan. The integral from 0 to infinity of sine x over x dx, that is a nice pi over 2. Ayan. Thank you guys for watching. I really enjoy making this kind of content. Kahit na, the term just started and, new profs to meet, new things to attend to, new responsibilities. I'm just enjoying doing this. So, ayun, if you have any suggestions on what I should do next, just comment na lang or like message me. So, thank you guys. Keep learning.